Gravitational potential energy is a difficult concept that you're going to come across in HSC physics. It talks about how the gravitational potential energy of an object changes as it moves significant distances from a planet, significant enough so that the gravity actually decreases as well. So that's where the complication comes into play. The chart in front of you is a graph that's commonly used to explain the concept, so it's worthwhile just having a look at that to organise our thoughts around it. Here we have a vertical axis. The vertical axis is the gravitational potential energy. We have positive up here, we have a 0 point there, and down the bottom we have negative. Along the horizontal axis we have the distance between the mass and the body providing the gravity, in this case the Earth. Sometimes that is given as R. What we can see here is a curved line. Now the curved line is describing how the gravity or the gravitational potential energy changes. You can see here that the gradient is getting less and less and less. It's approaching a gradient of 0, it never quite gets to 0, and it never quite gets to the horizontal line. So we can see here that as the distance increases, it's approaching that line. On the other side of the line here, it stops abruptly around about there, where this dotted line here is. Now that dotted line is representing the radius of the Earth, which represents the distance from the centre of mass of the Earth to the object. So when the object is on the surface of the Earth, it has a gravitational potential energy of this amount here. It can't get any more than that or any less, because the radius of the Earth won't allow it to. If we now look at the the definition given in your syllabus, the gravitational potential energy of an object, that's the absolute value of it, is defined as the work done in moving an object from a very large distance away, or infinity, to a point in a gravitational field. So extremely long distance away, moving to a certain point, the gravitational potential energy is equal to the work done in moving that. Now if you can think about when you're moving an object, it's actually going to start falling by itself. You're not going to be doing work on it. So there's sort of like negative work comes into play, where that negative sign we'll talk about later on is also to do with that as well. If we now look at the equation that's given in the syllabus, it's on your formula sheet as well. It's here in front of you in the red box. We have a couple of terms there that needs explaining. The EP is of course the gravitational potential energy. The G is the universal gravitational constant. It's found in your data sheet. M1 would be one of the masses, let's say the Earth. M2 would be the object possessing the gravitational potential energy, and R is the distance from the centre of the Earth or the planet to where the object is. Right, so that's that equation outlined. You've got the negative sign here as well. This negative sign we'll talk about that in a second. If we now extend this distance to infinity, we can have a look at that and saying that is where this line will hit the 0 mark. Now because infinity can never be reached, we can also say that the 0 point of gravitational potential energy is never reached as well. And if that's never reached, it can never cross over into this positive region. So we never get any gravitational potential energy in this region of the graph. It's always below it. It's always trying to get to 0, but never ever gets there. So that's a bit of an explanation of the negative sign there, that we can never get across to that. As I said before, because the work done is a negative work, is something to do with that negative sign as well. We mentioned this before down here, that the EP will never get any lower down in this graph because the radius of the Earth won't allow it to. So that's the significance of that dotted line intercepting that dark line there, and it stop it from going any further. Now a lot of the questions will talk about launching a satellite into orbit. Now we're going to try and look at that with reference to this graph. We have position 1, which is on the Earth's surface. That would be the rocket on the launch pad. We have position 2, it's some height above the surface of the Earth. You can see here it's one radius and a second radius there high, so that'd roughly be, incidentally, probably about 12,000 kilometres high. Quite a high orbit actually. But anyway, even so, let's have a look at the analysis of the gravitational potential energy. We can see when it goes from position 1 to position 2, the gravitational potential energy has moved from a negative value to a less negative value or a more positive value. Now this equates to an increase in gravitational potential energy. So getting from the surface of the Earth into orbit involves an increase in potential or gravitational potential energy. Because there has been an increase in potential or gravitational potential energy, we say that that work must have been done on the rocket or by the rocket. Now we say that the change in potential energy is the work done. In a rocket launch, this increase in EP has originated from the chemical potential energy in the rocket fuel. You have to think about the conservation of energy in that case as well. So we have W's work is equal to the change in the change in gravitational potential energy, which can be equal to the gravitational potential energy in this position minus the gravitational gravitational potential energy in position 1. So there we have a good outline of a very difficult concept. Some ways of expressing yourself are outlined there too. So if you ever get to an extended response question, or you got to try and explain something about gravitational potential energy, if you can remember that chart, it'll put you in good stead to be able to gain some of the marks, if not all of them. I think I might post another clip later on showing how some of the past HSC questions have gone and how to solve them.